Okay, so today I'm going to be reviewing a paper on multi-perspective occlusion management for VR and AR navigation tasks. Um, so in AR and VR, a common problem is how to kind of give as much information to the user as possible in a kind of digestible way to the user. And so when we face problems like occlusion and we want to try and give the user more data so that they can kind of see around a corner or kind of see kind of the streets in this busy city map, we kind of have to see how can we give this information in an easily digestible way. And so one strategy could be to just use an X-ray view. So for the city, we might just block out, kind of make the buildings that are blocking our point of interest, make them transparent. And this works, and we can see that red dot at the point of interest, but it adds a lot of visual noise, and we can't really get a good sense of the area around that red dot. And then looking on the right, we kind of have a different problem where our we're trying to see that hallway, and now we can see it very clearly with this X-ray view, but we can't see the wall to our right very clearly anymore. And that's kind of important that we can see that wall just so that we can avoid like bumping into it, for example. So what are some other options that we could try? Well, we could like try doing a cutaway. So instead of having an X-ray, we could just get rid of the occluding component completely. And this could work for some applications, but uh, com if that piece that we're going to cut away is actually important to what we're trying to do, then it might not be such a good idea. Another strategy could be to use the exploded view, so we can kind of see what that could look like with that controller on the right. And this is useful in some cases again, but in a lot of cases it's just a lot of visual noise, and if you have anything else going on, it's kind of too much. So another thing we could do is we could kind of allow the user to move around the environment through kind of smaller motions in a so they might take like one step and then they kind of travel 10 steps in the virtual environment. Um, so this is kind of a good way of like allowing them to get around a bigger space easily. But the problem is that it can be a little bit unintuitive because it doesn't match up. They do one step and then the interface moves 10 steps. And then the other problem is that you can't really use this type of idea with AR because um, like in AR, you're always fixed to where you are in the real world. You can't move faster than you can move in the real world. So another strategy could be to use like a virtual billboard that kind of shows a camera feed in a floating pane somewhere. And this can be helpful in some cases, but again, it doesn't really give you any kind of depth perception in that video screen, and it's also kind of discontinuous with kind of the rest of the scene around it. And so um, there could be better options like trying to fuse multiple perspectives into a single unified perspective. And that's what this paper tries to do. So how does that work? So we can look at the picture in the upper left. This is kind of an angled view of the city that a user might be seeing. And let's say that we have this kind of point of interest hidden behind some of the buildings in this image. So how can we get the user to see that point of interest? Well, we can try and fuse it with the top view of the city, like centered above that point of interest. And so if we can see in the bottom left, we have that top view. And what we do is we take that top view and we translate it so that it fits on the kind of where on the ground of the kind of angled view. and then we're kind of able to merge the two images together. And the way we blend the images is we use a Gaussian. So when we're really close to the point, the top view is kind of takes priority, and then as we move further and further away from that point, slowly we get more of um, the kind of angled perspective, and we can see some of more of those 3D buildings. And so now looking at this idea of fusing multiple perspectives for like a different task, we can think of moving in a hallway, and then we have a side corridor, and we want to try and see in that corridor before we're like directly in front of it. And so we have a camera set up that you can see in green in these pictures that's looking into the hallway. And uh, so what we do is we take that feed from that that camera, and uh, we shift it over to the user's view. Like looking at that left picture, we have the user is the gray camera. We take that green camera view and we shift it over to the gray camera view. And then on the right, we can see that we kind of snap the kind of front edge of that view into the kind of interface between the hallway and the side corridor. And then by doing that, we kind of connected the real world view of the hallway that the user is seeing to the virtual uh, projection of the side corridor that the user is seeing. And so now the user can see down that side corridor um, at the cost of having that corridor at like the wrong angle, um, and it like would actually be if it was in the physical space. And so here is kind of an example of what that looks like. So we see the side corridor that comes off at 90 degrees, but we can kind of, even though we're looking at it at an angle, we can see right down the corridor and see like that ghost that's in that corridor. So now we can look at the user study that they did to evaluate their platforms. So they did uh, two user studies with the city interface that they made. So the first was kind of just tracking a target that's moving around on the streets of the city. And then the second one was they had a bunch of colored spheres, and then the user simply had to find two colored spheres that matched. And the results for both of these tasks were pretty good, pretty much in favor of their new interface compared to a control interface with like none of this kind of multi-perspective blending thing. And so what they found was that their interface was kind of allowed the subjects to move much less, and it also allowed them to complete that sphere matching task much faster. Um, and then looking at the AR task, so they had the first task was they had a stationary object somewhere in some hallways, and they had to find it. And this showed some pretty decent improvements in both distance traveled and the completion time for this task. But then they did a kind of a similar task with where instead of searching for the target, they had to ambush the target. And if they were kind of detected by the target, then the target would like start running away. And then they would have the option of either like chasing down the target or trying to presumably maybe go around some hallways and find the target at a different place. And so for this one, they did find that the users had didn't have to like walked a little bit less because uh, more of these users chose to like ambush the target rather than like being spotted and then chasing after them. But in the end, the task completion time wasn't all that different between the control interface and their new interface that they made. And this could be just because um, it didn't actually like since you could just chase down the target when you get spotted, there wasn't as much benefit in terms of like how fast you got the task done. Either way, you could either spend a little bit more time to ambush, or you could just rush in and then run after them, and it would take about the same amount of time anyways. Um, and so now we can move on to looking at what can we learn from this paper. And this paper really had some really good results about saying that their interface works and helps with improving the navigational efficiency. Um, and it kind of presents a new paradigm for like how we can add multiple views in a natural way and how we can overcome some problems of occlusion. But still, even though it showed some promising results, there are still some problems in that it does actually distort the view, and um, this will always create some kind of problem. And so it may not always be the perfect tool for every job. And uh, this is one of the reasons why it's really important that in the future this type of interface is compared against more traditional interfaces like X-ray and cutaway to see where each type of interface shines and where it should be used. And then one of the kind of limitations of the city VR interface in particular is that um, the kind of top view doesn't allow you to see under bridges. And so there's no way, if you have a point of interest under a bridge, there would be no way to um, disocclude that view. And so in this kind of case, this would be one of the cases where you might want to use like an X-ray or cutaway to see under that bridge. And then for the AR task, one of the limitations is that you need a geometric model of your corridor. And this isn't a problem if you have kind of very simple um, like a very simple building with simple corridors and hallways, but if you're in an unknown environment or maybe you just have a kind of a complicated building shape, then this interface then you might not be able to use this interface. So that's something to keep in mind. And that's all I have for this review, and thanks for watching.